Hello everyone. Today our topic is composition of functions. The composition of two functions f and g is the new function h, where h of x equals f of g of x for all x in the domain of g, such that g of x is in the domain of f. The notation for function composition is h equals f compose g, or h of x equals f compose g of x, and is read as f of g of x. The procedure is called composition because the new function is composed of the two given functions f and g, where one function is substituted into the other. Again, two functions f a to b and g b to c can be composed to give a composition g compose f. This is a function from a to c defined by g compose f of x equals g of f of x. Consider, for example, that f of x equals x plus 3 and g of x equals 2x plus 5. Find f compose g of x and g compose f of x. F compose g of x equals f of g of x, which is f of g of x equals 2x plus 5, which is equals 2. Now in the function f, instead of x, we substitute 2x plus 5. 2x plus 5 plus 3, which is 2x plus 8. And the function equals 2, which is g of x plus 3. Now in the function g of x, we replace x by x plus 3. So we'll have here 2x plus 3 plus 5, which is 2x plus 11. From this example, it's obvious that f compose g is not equal to g compose f of x, although in some cases they are equal. Example 2, let g be the function from the set ABC to itself such that g of A equals B, g of B equals C, and g of C equals A. And let f be the function from the set ABC to the set 1, 2, 3 such that f of A equals 3, f of B equals 2, and f of C equals 1. What is the composition of f and g, and what is the composition of g and f? The composition of f compose g is defined by f compose g of A equals f of g of A. G of A equals B, so this is equals f of B, and f of B equals 2. F compose g of B equals f of g of B, which is f g of B equals C. So we'll have here f of C, and f of C equals 1. F compose g of C equals 2 f g of C. G of C equals A, here, f of A equals 3. Now regarding g compose f, it's not defined because the range of f is not a subset of the domain of g. Here we have the graphical representation of the composition of the functions f and g. The function g assigns a to b, and the function f assigns b to c. So f compose g is the function that assigns to the element a of A the element assigned by f to g of A. That's to find f compose g, we first apply the function g to A to obtain g of A, and then we apply the function f to the result g of A to obtain f of g of A, which is f compose g. Note that the composition f compose g cannot be defined unless the range of g is a subset of the domain of f. Next example, given the function f of x equals x squared and g of x equals x plus 4, find f g of 1 and g f of 1. First, f g of x equals f of x plus 4. Now in the function f, instead of x, we substitute x plus 4. Hence, f g of 1 equals 1 to 5. Next, g of f of x squared. Now in the function g, instead of x, we substitute x squared. So we'll have x squared plus 4. So g of 1, which is 5. Again, note that F compose G is not equal to G compose F. And as a last example, given f of x equals 3x squared plus 5 and g of x equals square root of x plus 3, determine f compose g of x. F compose g of x equals f of g of x, which is 3 g of x squared plus 5. 3 g of x is the square root of x plus 3, all square plus 5, which is 3x plus 3 plus 5, which is 3x plus 9, 9 plus 5, 14. In the end, some facts about composition. If the functions f and g are one-to-one functions, then the function g compose f is also one-to-one function. If the functions f and g are onto, then the function g compose f is also onto. Composition always holds associative property, but does not hold commutative property. Also, I mentioned earlier that f compose g is not equal to g compose f. For today, that's all. Thank you.